Hello, folks. Sifu here again. We're going to continue our discussions on science. And for today's episode, we're going to talk about quantum mechanics. In the last episode, we talked about string theory. This one, we're going to talk about quantum mechanics. Haven't seen this video, so let's see what it's like and get to it.
In our world, things are usually straightforward and logical. A car is either at rest or moving. The stereo is either on or off. A cat is either a dead or alive, one state or the other. There is no middle ground or a combination of states. However, the same can't be said about the world on the most fundamental level, on the scale of the most basic particles we're made of. On that scale, a particle doesn't exist in one state or the other, but in a number of states all at once. Like Schrödinger explained, a cat of the fundamental world would not be either dead or alive. It would exist between the two states, both dead and alive. This he called superposition.
And for any of you that have heard of Schrödinger's cat, that's what this was referring to. So this kind of helps explain that. If you've never heard of it, it means that you know there's a cat in a box, but you don't know if it's alive or dead unless you observe it. Right? So superposition, it's either or.
A particle exists in a combination of states. Strange, right? But this is the strange realm called the quantum world, ruled by quantum physics. It has become quite a popular subject in recent years, and the bulk of credit goes to science fiction. The theories of alternate universes and time travel are certainly keeping us entertained, but what exactly is this subject that is feeding the world of sci-fi with so much great content? What is quantum physics? Quantum is a Latin word that literally means how much, but it is used for talking about the minimum amount of some physical entity. Aptly, we use it to represent the most elementary particles that are the basics or the minimum of this very big world. So, quantum physics deals with the foundation of our world, the electrons in an atom, the protons inside the nucleus, and the quarks that build those protons, as well as the photons that we perceive as light. These constitute everything that we are made of, both matter and energy. That sounds pretty simple, right? So how is this any different from regular physics? The regular physics is the physics that deal with Newton's laws of motion and its related mechanics. This is more formally called classical physics. This is the physics of our day-to-day lives, the rolling of balls, the rotation of the Earth, and the mechanics of engines.
Okay.
However, if classical physics is so wide-ranging, why was it insufficient? We must go back in time to the 1900s to witness the birth of quantum.
Nice little addition of the DeLorean there for the movie buffs out there.
Physics. This was a time when scientists were still unable to understand the observations of the photoelectric effect. Simply put, the photoelectric effect is a phenomenon in which light hits metal, resulting in the knocking off of electrons. According to normal physics, the electrons should start escaping the metal when the brightness of the light exceeds a sufficient limit. Yet, in reality, it was the color of light that determined whether electrons would be emitted or not. This was when Albert Einstein turned to Max Planck's equation. Planck's equation stated that light waves carry energy in small packets called quanta. This explained how each color of light had a specific amount of energy associated with its wavelength. This energy, in turn, was responsible for the electrons getting knocked off. Einstein used Planck's equation to propose that light not only acts as a wave, but also as a particle later named photon.
So I knew about that, but I didn't realize about the quanta pieces within the photons. That's cool. That's very cool.
Since then, physicists realized that regular physics simply wasn't sufficient to understand the microscopic world. They termed this regular physics classical physics, a physics of the past, and another branch of physics dealing with the fundamental world as quantum physics. This world is therefore now called the quantum world. Let's be honest, our brains are made for this macroscopic world, where they can understand the running of a car on a road or the mechanics of a pen. But they are unable to initially understand the quantum world.
Well, so that's something that's learned over time, right? I mean, as you develop from infancy up to adulthood, these are things that you start to figure out. If you roll a ball a certain, put a certain amount of force behind a ball to roll it, can make it go further, or lesser, right? So those are basics that people start to understand, but they don't realize that they're actually understanding standard classical, in this case, physics.
For instance, imagine you're standing in front of a massive wall and want to reach the other side. This wall is surrounded by deadly alligators, so your only options are either climbing it or making a hole through it. However, if you don't have energy enough to do either, you won't be able to reach the other side, right? Well, that's how the macroscopic world works. But in the quantum world, a particle can still go through such an energy barrier without sufficient energy.
Yes.
This ability is called quantum tunneling. This phenomenon is responsible for the nuclear fusion that fuels the energy production of stars. As complicated as quantum mechanics may seem to some, it gets special love from popular culture. You may often see the dramatization of unusual quantum phenomena depicted in our macroscopic world through movies and TV shows. Take, for instance, the Marvel Universe. Marvel movies are famous for their heavy use of quantum physics, at least the words, if not the actual physics. Even though most of it is fiction being labeled as quantum physics, there are some scenes that are based on theoretical concepts.
Yes.
One of these is the multiple realities of Doctor Strange. First, let's understand the quantum physics on which it is based. This subject deals with particles in terms of probabilities. For instance, while talking about the position of an electron, a physicist might say the electron is most likely to exist in this range of lengths, say between 1 to 3 units. However, the same thing can be interpreted as electrons existing in different realities at different positions in the possible range. So it can exist at 2 units in one reality, while at 3 in another reality,
Yep.
or any other possible number between its most probable range. In short, there are many realities covering each possible position of the particle.
And this goes back into the Heisenberg uncertainty principle, as mentioned.
See, mathematics and its implications again. A massive magnification of this concept is what we see in Doctor Strange's multiple realities. Each possibility of a reality is a separate universe in itself, allowing there to be multiple universes. Another very famous use of this concept is in the beloved movie Endgame, specifically its idea of time travel. The movie understands that if we change the past, the future will also be changed. So, if they all go back in time and kill Thanos, who will bring about the apocalypse, and why would someone travel back in time to kill him? This issue is called the grandfather paradox. A solution to this paradox was given by David Deutsch. Yes, that David Deutsch mentioned by Tony Stark in the movie. Deutsch said that the only way to remove this paradox is if we talk about the events in terms of probabilities in the same way we talk about particles. In other words, changing the past only has a certain probability of happening. That means that they might not even be able to kill Thanos in the past, probabilistically speaking.
Yeah.
To sidestep this paradox, the clever thing they did was go back and bring all the Infinity Stones back to before they were destroyed. Returning them to the same time would avoid any change due to the missing stones. One must admit that it was indeed a clever fix. Quantum physics has certainly fed a lot of fiction to the general masses, but it has also become a necessary area of knowledge. It has assimilated itself into other domains of science and is still expanding. For instance, quantum computers are aimed at doing tasks that are too complex for a classical computer to perform.
Yes.
There is heavy focus on building a better communication system using quantum physics for better safety and privacy. Energy production via a nuclear reactor is only possible due to the study of nuclear fission via quantum physics. It is also deeply ingrained into the subject of astrophysics. After all, the best way to answer the questions of the universe is if we understand its most basic building blocks. Regardless of whether we fully understand the subject or not, it is certainly growing in importance. With more talk of quantum physics to come, it is safe to say that it will soon become an integral part of our lives.
Nice little animation there for showing Marvel. That was actually pretty cool. They did a pretty good job with that. The quantum computing thing is huge. And one thing that they mention in there, they talk about communication, and quantum communication something that we've already started doing, and I see as a recommended quantum entanglement, following up for, I think it's this exact same YouTube channel. Anyway, they talk about quantum entanglement and being able to communicate. So what scientists have been able to do is take two particles and use what's called spin, particle spin. And they basically, they spin and they rotate. Well, if you get them spinning at the same rate, same oscillation, same everything, you can transmit data from one to the other instantaneously, and it cannot be interrupted. It cannot be intercepted. So this is huge, a huge breakthrough, and it's instantaneous transfer. So it doesn't matter how far they are apart. I think right now they're up to several miles apart that they're able to do this by just using the quantum entanglement. So it's pretty fascinating stuff. I highly recommend you give it a chance and go take a look at it. But anyway, thank you for watching. I appreciate you guys being here. Please like and subscribe, and we'll see you on the next one. Bye-bye.